So for this section, we're going to look at division by a monomial. In other words, we've got a polynomial in the numerator and it's divided by a single monomial. It's just a single term in the denominator. We'll do something a little bit more complicated later, but for right now, that's the only type of problem we're going to deal with. Now, when you have just a single term in the denominator and you have multiple terms in the numerator, what you basically do is split them into separate fractions and then reduce each fraction. So let's do that with this first one. I'm going to put everything over that denominator, which is a negative 3x to the power of 5. And I'm going to separate them with addition signs. I'm going to put these negatives with the term, okay? Because that'll make it a little clearer as we reduce. So all three of these fractions have a denominator of negative 3x to the 5th. Now what goes in the numerator is, well, the first term is 3x to the 9th. The second one is a positive 27x to the 6th. The third one is a negative 18x cubed. Now I'm going to reduce each of them. Because I have put the signs with the terms and separated them by addition, it'll make it a little easier for me. So I'm going to say 3 divided by negative 3 first. Well, 3 divided by negative 3 is a negative 1. I don't really have to write a 1 if I'm going to have anything else in this term, and I am, because x to the 9th over x to the 5th, I subtract the exponents, I come up with x to the 4th. I'm going to put it in the numerator because that's where the bigger exponent is, so I have a negative 1x to the 4th, or negative x to the 4th. Now this one is going to be a positive divided by a negative. Now I know that there's a positive divided by negative, so the entire term will now be negative. I can go ahead and take care of that. 27 divided by 3, negative 3, of course, is negative 9. And I do the same thing with my exponents here. I'm going to subtract them. I come up with x to the power of 1, or just x. It goes in the numerator, so I don't have a denominator. Everything canceled in the denominator. Next, I have a negative divided by a negative, which is going to be a positive. It's really negative 18 divided by negative 3, which is positive 6. And this time I have x cubed over x to the 5th. So I'm going to subtract and have x squared. It has to go in the denominator. So I'm going to have to turn this one into a fraction with x squared in the denominator. Let's look at the next example. First of all, we're going to do the same thing. All of these are positives. Everything's positive, so it's really making my math a little easier. I'll separate them with plus signs. I'm going to put the same denominator for all of them. So 4m squared in the bottom of each of these fractions. And then I'm going to have the first term was 24m cubed. The second one was 8m squared. And the third one was 24m. And now I will reduce. 24 divided by 4 is 6. M cubed over m squared, I subtract and come up with m to the power of 1 in the numerator. That's just m. Plus 8 divided by 4 is 2. M squared over m squared is just nothing. It's 1, actually. So I've just 2 times 1 is 1. So next, we're going to say 24 divided by 4 is going to be 6. M to the power of 1, m squared. When I subtract those, I end up with m. I end up with m in the denominator. So it has reduced into 6m plus 2 plus 6 over m. Or it's the division is that anyway. Next, let's look at, these have some negatives, so that complicates our life, but let's do what we did before. Let's make the fractions and separate everything with plus signs. And that's the first 1, 2, 3, 4, 5. I'm going to have 5 fractions when I finish. They're all going to have a denominator of negative 5r. How many have I got? 4, one more. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 in the numerator. Okay, let's start putting the terms in the numerators. 45r to the 4th, and here's a 50r cubed. Here's a negative 75r squared, a positive 24r, and just 11. Now I can just treat them as individual fractions and reduce. Negative divided by negative is going to be a positive. Negative 45 divided by negative 5 is a positive 9. R to the 4th, I subtract these and come up with r cubed in the numerator because that's the bigger exponent. The second one is a positive divided by a negative. That's going to be a negative. it was 50 divided by negative 5, which is a negative 10. R cubed, subtract r to the first, or r to the exponent of 1. 3 minus 1 is 2. R squared in the numerator. This is a negative divided by negative, so it's just going to be positive. And it's going to be like 75 divided by 5, which gives me 15, right? I'll subtract 2 minus 1 again and just get r in the numerator. And here I'm going to have a positive divided by a negative, so it looks like this whole term is going to be negative. Now, the r's are going to reduce. They're just r over r is just 1, but 24 over 5 does not. I'm happy just leaving it as a fraction, sticking my negative sign out in front of the term, which is where it belongs. And the next one is also going to be negative, isn't it? Because it's a negative in the numerator and a positive in the negative in the denominator, positive in the numerator. But I don't see any way to reduce that one, so I just leave it like it is. I just moved my negative out in front of the term. Okay, let's try this one. This is just written a little bit differently. Division by the single monomial means each of these terms will be divided by the monomial. So it's really the same problem we had here. It's just written differently. So let's go ahead and write it. We have 1, 2, 3, 4 terms, and I'm going to have 4 fractions here. So I'll come up with each fraction will have a denominator of 2, a to the 4th, t, and I'll separate them with addition. And now let's fill in the numerators. I've got 4, a to the 10th, t to the 11th, and this is a negative 4, a to the 8th, t to the 9th, a positive 18, a to the 4th, t to the 5th, and a negative 8, a to the 6th, t to the 2nd. So each one individually, 4 divided by 2, that gives me a whole number 2. I've got a to the 10th, a to the 1st, 10 minus 1, 9 in the numerator is my exponent. And this time I say 11 minus 1 for the t's in the numerator, t to the 10th. This one is going to be a negative, only one negative in the set, so I'm going to say negative divided by positive. It's going to give me a negative. 4 divided by 2, that's a 2. Subtract these exponents for the a's. 8 minus 4 is a to the 4th, numerator. 9 minus 1 is t to the 8th in the numerator. And I have positive for this next term. 18 divided by 2 is 9. The a's are going to cancel. That's just a to the 4th over a to the 4th. But here I've got t to the 4th minus t to the 1st. So I'll say 5 minus 1 is t to the 4th in the numerator, whole number. And here I'll have the 1 negative again. So that term will be negative. 8 divided by 2, 4. And I say 6 minus 4 for the a exponents. That's going to give me 2 in the numerator. And 2 minus 1 for the t's. That's going to give me just t to the 1st, or t, in the numerator. This turned out to be all whole numbers. And I'm looking at them, just making sure that the highest degree was listed first. And it is, because this would be to the degree of 19. Let's do a few more, just for practice here, because this is just more of the same. We'll split these out and make 3 different fractions, 3 terms in the numerator for this one. I've got 5x squared y for all the denominators, and I'll separate them with addition. So the first one, 5 x squared y squared is the first one. The second one is 25 x y squared. And the third one is a negative 10 y squared. So start reducing them. 5 divided by 5 is 1. X squared divided by x squared is 1. All I have here is 2 minus 1 for my exponents for y, and I end up with just plain a y in the numerator, y to the power of 1, right? It's going to be plus, because both of these are positives. 25 divided by 5 gives me a coefficient of 5. This I'm going to have to say x squared minus x gives me x, but I have to put it in the denominator. and the y has to go in the numerator when I subtract those. So this became an interesting term, 5y over x. Now my third term is going to be negative because negative divided by positive. It's actually going to be a negative 2. And then I don't have any x's in the numerator, so I'm going to have those stay in the denominator. I do have in the numerator, I can say 2 minus 1 and have y to the power of 1 in the numerator. I'll write another one. 4 terms for this one. All of them have a denominator of 6a cubed b. I'll separate them by addition. Okay, I'm running out of room. Hopefully you can see it. The numerators, I'm going to say 48, a to the 7th, b to the 8th, and a negative 30, a to the 5th, b to the 6th, a positive 48, a cubed, b to the 4th, and a negative 18, a to the 6th, b squared. So 48 divided by 6 gives me 8. A to the 7th over a cubed leaves me with a to the 4th in the numerator. And then for the b's, I say 8 minus 1, b to the 7th in the numerator. This one is going to be a negative term because I've got to have a negative divided by a positive here, so I'll go ahead and do that. And it's 30 divided by 6 gives me 5. A to the 5th over a cubed, I'll subtract and have a squared in the numerator. And b to the 6th over b to the 1st, I'll subtract and have b to the 5th in the numerator. Next, it's going to be a positive term because all of them are positive. 48 divided by 6, well, that gives me an 8. And I have a cubed over a cubed, which is just 1. I cancel those, and I say b to the 4th over b to the power of 1, subtract those, and get b cubed in the numerator. My last term will be negative because it's a negative divided by a positive. Negative 18 divided by 6, negative 3. A to the 6, subtracts 3 from 6 and come up with a cubed in the numerator. And b squared over b is just b to the power of 1 in the numerator. Last example. Let's just take each of these and write them over the denominator, 5a to the 6th. So I'll come down here and do it. And I'll separate them all with addition. I'll settle the issue of the sign later, as we've been doing. Now I'm going to fill in, and this time, if the sign is there, I'm putting it in the numerator. Notice the only time I put the sign in the denominator is or negative in the denominator is if they are divided by a negative number. Otherwise, I'm putting that sign that goes with the term in the numerator. So I say 30 divided by 5 to get 6, and a to the 6 over a to the 6 is just 1. So that term is just 6. Next, this is really negative 25 divided by 5, or negative 5. A to the 9th over a to the 6th, I subtract and come up with a cubed in the numerator. And now I've got 20 divided by 5, which is 4. And a to the 4th over a to the 6th, I'm going to have a squared, but the bigger exponent is down here, so I have to leave it in the denominator. Hopefully that's enough practice to get you going. When you are dividing a polynomial by a single monomial, split it up and then start reducing fractions.